Suppose you have function f of x equals to sine x, and you are interested in calculating the limit of sine x as x goes to infinity. Well, what was the behavior of sine function? Remember, for a sine function, the function oscillating non-stop, and this is, for example, the behavior of your sine. Goes up and down on both sides. So as x goes to infinity, we don't know what is the exact value of the function. So you're going to say that, hey, the limit does not exist. The limit doesn't go to infinity. The limit doesn't exist. We don't know what is that y value on the right-hand side. What about the limit of cosine function? The limit of cosine of x as x goes to infinity has the same behavior. The limit doesn't exist. We don't know what that number is. We know it's a number, but we don't know what is the number. We cannot find that unique number representing the limit of the function. What if I write this as n? What is the limit of sine of n as n goes to infinity? Well, the same behavior, but if it's n, then the graph is not continuous nicely. The graph behaves like this. It's like dot. You have a lot of gaps. It's a discrete graph. But again, when n goes to infinity, what is the y value of your function? Let me take this one and move it a little bit around here. The limit doesn't exist. The same as the limit of cosine of n as n goes to infinity. The limit doesn't exist. So don't write it as infinity because it's not infinity. You just write it does not exist. It goes to a number, but what number is that? We have no idea. Now suppose we're interested in calculating the limit of inverse tangent of x divided by x as x goes to infinity. You can write it this way as well. What is the limit of arctangent of x divided by x as x goes to infinity? Remember the behavior of inverse tangent. Inverse tangent behaves like this. If you try to graph inverse tangent, this is the graph of inverse tangent roughly. Arctangent of x. So as x goes to infinity, when x goes to infinity, where does your arctangent go? When x goes to infinity, arctangent goes to pi over 2. So here you can write this guy as the limit of arctangent of x as x goes to infinity divided by the limit of the denominator, which is x as x goes to infinity. The limit of arctangent of x is nothing but pi over 2, and the limit of x as x goes to infinity is just infinity. You have a number divided by infinity, so it is equal to 0. So the limit exists, and the limit is equal to 0. This is an important formula for students. They forget about the limit of arctangent of x as x goes to infinity. You can remember the behavior of this graph. which is inverse tangent. And when x goes to infinity, it's getting closer and closer to pi over 2. And when x goes to negative infinity, it's negative pi over 2. So remember these formulas. The limit of arc tangent of x as x goes to positive infinity, it is pi over 2. And the limit of arc tangent of x as x goes to negative infinity is negative pi over 2. You can separate the limit into the limit of arctangent of x as x goes to infinity divided by the limit of x as x goes to infinity. You end up with pi over 2 over infinity, or a number divided by infinity, or just 0. So the limit of this function is equal to 0.